Jai Hind everyone. So in today's lecture, we are going to learn about the topic the trees under the subject discrete structures and theory of logic. So in this lecture, we are going to know about trees, definition, binary trees, binary tree reversal, binary search tree, these all. So let's start. What do you mean by tree? So a tree is a connected acyclic directed undirected graph, not directed graph. So tree is what? It is a kind of a graph which is having acyclic properties. So what are acyclic properties is that there should not be any kind of cycles inside it and it should be undirected. So there is a unique path for every pair of vertices. So if we are having any kind of a graph and that graph is known as tree, it means all the nodes would be connected to each and other with the unique set of edges. So a tree with, if you are having n number of vertices, then the tree would be having n minus 1 edges. So here in this example, if you can see that is the root node, okay, and root node is having multiple childs. So these are known as childs. So this is your internal node. These are all your internal nodes, and the node which is the last node which is not having any kind of child or other nodes connected to it, that would be known as the leaf nodes. Okay, so this is the graph which is known as tree because this does not contain any kind of cycles inside it. So I just said that if you are having n number of vertices, then there are n minus 1 number of edges. So here what are the count of vertices here is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 vertices. Okay, and we are saying that how many edges, if you have to calculate how many edges that your tree would have if you are having n number of vertices, then there are n minus 1 edges. So n minus 1 edges here is 10 minus 1, that is 9 edges. So where are those 9 edges? That is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so if you have to calculate the edges, then you should be having what? Number of vertices. So there is a simple formula for this. Now what are the various properties of tree? The properties of tree are, first one, there should be only one path available between each pair of vertex. So that's, I have already told you that there should be only one path. Okay, there should not be more than one path. If you are having more than one path, then it will create cycle. So in tree there should not be cycles. So first property is that there is only one path that would be available between any pair of vertex. The second one is, if a graph G, there is one and only one path between each pair of vertex. So what does it say? It says that if you are having a graph known as G, and G would be known as tree only and only if there is only one path between every vertex, each pair of vertex, then that graph would be known as tree. Okay. Now the third property is, a tree with n vertices must have n minus 1 edges. That's already has been covered in the previous slide. And the last one is, a graph is a tree if and only if it is minimal connected. So what is minimal connected here is, minimal connected is like that every vertex should be connected with any another vertex. There should not be, you can say there should not be, you can say more than one path available for the connection. So if I am saying that if I am having a node like this, and if these nodes are connected, then if there is a minimal connection available, that is one connection, one edge between two nodes, it means this particular graph would be known as tree. If there are more than one connections, now what is this more than one connection? It means if this is the node 1, node 2, node 3, node 4. So node 1 is connected to Node 1 is connected to node 4. So here it is forming a cycle. So this cycle will not be your, this particular graph will not be your tree because it is containing a cycle. So these are the basic properties of the tree. Now come to binary trees. What is binary tree? So binary number itself suggests that it should be having 0 and 1. So what are binary trees? A tree whose elements are having at most 2 children. They are known as binary tree. It means if there is a node, like if this is a node, so it should be having only 2 childs. Okay, so at most 2 childs, not beyond 2 children. So that would be known as your binary tree. Now, what are the basic terminologies that has been used under this tree category? First one is the root. A binary tree that has a unique node. Okay. And what is that unique node? That is your first node of that particular tree. That is known as your root. Okay. Now, the next is left child. So, what is left child? The node which is on the left side of the root node. That is your left child. So, this is the left side. So, this is the left child here of this particular root node. Okay. Now, what is the right child? So, right child is the node which is on the right hand side of that particular root node. So, this is my right child here. Fine. Now, what is the parent? Parent is a node having a left or right child, or both are called the parent of the node. So, if I want to say that you have to find out the parent of this particular node, so that is what? That is the root node. Root node is the parent of this particular node. Same, likewise, the parent of right child is your root node. Or, if you want to say that you have to find out the parent of these 2 nodes, then again that will be your root node. Now, what are the siblings? Sibling is 2 nodes having the same parent. So, here in this example, left child as well as right child, both are having the parents which is common. Now, it means left child and right child are siblings. Fine. Now, what is leaf? A leaf is what? A node which is having no children of itself. So, it means this is the last node of the tree. The number of leaves in a binary tree can vary from 1 to the what? Half of the number of the vertices. So, basically, leaf node is what? That a kind of a node, if you can say this is what? This is the graph. So, in this particular graph, there is no cycle. This can be termed as tree. So, in this tree, if this particular node is not having any kind of child, it means that is the leaf node. That is the last node of that particular tree. Now, what is descendant? So, descendant is a node that you can say which is known as the descendant of another node if the child of the node or the child of the some other descendants. So, basically what descendants is, all those nodes in the tree are descendant of the root. Yani, it means if there is a root node and other are the childs, it could be the internal node, it could be the leaf nodes. So all these internal nodes and leaf nodes are the descendants that are being driven by that particular root node. So that are known as descendant nodes. Now, what is left subtree? Left subtree is that particular subtree, a part of the, if you are having, let's go to the first slide. In this tree, if I want to say what would be your left subtree. So, if I want to divide this tree into 2 sections, so the division of this particular tree will be done by the root node. So, if you want to divide, it will be divided like this. Okay. So, what would be the left on the left side? This particular tree. So, this particular tree is your left subtree. And if I want to say what would be the right subtree, so right subtree is this particular tree, which is on the right side of the root node. Fine. So, this is known as your left subtree. So if we are having an example here, there is a graph here which is having a root node A and other are the descendant nodes, then we have to find out. The question is, which node is the root? Now, which node is the root here? Obviously, the highest node, the level 0 node, the first node of the tree is known as the root node, and here the root node would be A. Okay. Now, next question is, which nodes are the leaves? So, leaf nodes are those nodes which don't have any kind of children. So, what are those? It's G, H, I, L, M, N, O. These are all the what? Leaf nodes. Okay. Now, the next question is, name the parent node of node E. So, here is node E. This is. And you have to find out the parent of node E. So, who is the parent of the node E is? That is B. Okay. Because B is, E is driven by the node B. So, here the parent would be B. Now, what do you understand by level of a node? So, level of a node is, you can say, distance from the root node. So, if I have to calculate the distance of node E, then node E will be, the distance will be calculated by the node A, from the node A. So, it means that you are calculating the level. So, the level of the root node is defined by 0. So, if I want to say the level of this, that is 0. Okay. So, level of node A is defined by 0. And now, what would be the level of E then? If I have to calculate the level of E. So, we are starting from A. We are going to E. Now, 0 to the 1 and to the 2. So, what will be the level of node E? That is 2. Okay. So, the level of all other nodes in your tree is 1 more than the parent node. Okay. So, parent node would be having only, if the parent node of, you can say the parent node here is A, root node, it is having 0, then child will be having a kind of an increment to their level. Okay. So, that increment will be, if you are jumping to node B, it will be 1. If you are again going to node E, it will be 2 and so on. So, maximum, if you have to calculate the maximum number of nodes in any level, so if you are having n number of levels, then maximum level will be 2 into n here. Okay. Now, the next is depth or height of the tree. So, what do you mean by depth? So, basically the depth or height of the tree is defined by the maximum number of nodes in a, you can say, branch of a tree. So, what are the maximum number of nodes existing in a tree? So, that is known as depth or the height. This is more than the maximum level of the tree. It should be more than the maximum level. So, it means the depth of the root is 1. So, we will be starting from root node and the depth of the root node will be considered as 1. The maximum number of nodes in a binary tree, which is having a depth D, is 2 into D minus 1. So, if I have to calculate this particular depth of this particular graph, then I am starting from the root node and the depth of the root node will be starting from what? 1. So, here 1. Now, at which particular node you want to traverse? So, if I want to go to J, this particular node, so what will be the depth here? 1, 2, 3, 4. So, the depth here will be 4. Okay. Now, next is external nodes. So, what is external nodes? The nodes which have no children and which are also known as terminal nodes. So, do remember, if you have to find out the external node, that nodes which are having no children are also known as your external node or terminal nodes. So, what are the internal nodes? In this particular sign here, These are the external nodes. These nodes are not having any kind of children. What are internal nodes? The nodes which have one or more than one children are called internal nodes. So at least any node would be having at least one children. It could be one or more children, so that particular node will be known as your internal node. So here internal nodes would be all those nodes which are having at least one children. So it is D, E, F, J and so on. These particular nodes are known as internal nodes. Okay. So now come to the traversing of tree. If you want to traverse a tree, how and what are the various ways that you can traverse a tree? So traversing means that you have to visit each and every node of the tree. You have to start from root node and then you have to go to each and every node which is connected in the tree. So there are three standard methods that are being followed. So first one is your pre-order, second one post, and third one is your in-order traversal. So what is pre-order traversal? So in pre-order traversal, you have to visit the root of the node. First of all, you have to visit the root of the node and then you have to traverse the left side and then right side. While in post order, what you have to do? You have to traverse the left side first, left subtree first. And then you have to traverse the right side and then in the last, you have to visit the root node. And in the in order, what you have to do? You have to traverse the left side first, then you have to visit the root node and then in the last you have to visit or traverse the right side. So for remembering this, you can write it as, for the pre-order traversal, you have to visit the root node first, that is R root node. Then you have to traverse the left side or left subtree L and then you have to traverse the right subtree. So that is again R. Okay. And in post order, what you have to do? You have to first traverse the left side. Post order. So post order means you at last you have to visit the root node. So either if I want to say left child LC, RC is your right child. Here you have to, in post order you have to visit the root node at the end. So here I can write LC. First of all, I will visit left child and then I will visit right child and then I will visit root node. Fine. In order traversal, what you have to do? You have to traverse the root node in between the traversal of left and right child. So what will here? You can write left child first, then root node and then right child at the end. So this is the traversing. So here is an example. There is a graph. You have to find out what would be the pre-order, what would be the post-order and what would be the in-order traversal. So as we all know, in order you have to go to what? First left child, then root node and then right child. Okay, so this is the pre-order. So if I have to visit all these nodes in this graph and I am starting from where? From the root node. Okay, so this is my root node. Now I am doing what? I am doing the in-order traversal. So in order traversal, first of all, I have to visit all the leftmost nodes. So what will be the leftmost nodes here? So first of all, I'll go to 1. Okay, so in order, I'll go to 1. Then I will jump to left side, that is 2. And then I will again go to 3 because 3 is the leftmost node available. So in order, the first one will be your 3. Fine. Now what again it is saying, after completing left hand side, you have to write the root node. So what is the root node here for 3 is 2 because this is a subtree, right? This is a subtree and in the subtree, you have to first traverse the left node and then go to the root and then go to the right side. So 3, then again 2, here 2 and then you have to go to this particular node. Now again this node is not a leaf. This is a what? Subtree. because it is having a children. So in this particular subtree, you have to again traverse the left hand side first. So here, before going to 4, you have to traverse 5 first, because 5 is the leftmost node for this particular subtree. So again, the answer would be 5, and then you have to go to the root node, that is 4. And then again, because the 4 has been traversed and 4 is the rightmost node of this particular subtree. So next is the root node. So root node will be again 2, and 2 is already has been traversed. We will be again backtrack to 1. After returning to 1, because it is in order, you are saying that after completing left subtree, you have to write the root node. So this left subtree has been traversed fully. Each and every node has been traversed. Now the root node will be marked. So root node is 1. Now you will go to the right subtree. So for right subtree, again the in order technique will be followed, and it will say that you have to traverse left side first. So what will be the left side here? 7. Then again root node 6. And then when you come to this particular graph, this is again kind of a subtree. So in this subtree, again you have to traverse the left side first. So that is 9. But 9 is again a left subtree. So in this particular left subtree, you have to again what? Traverse the left side. But there is no node in the left side. Then you will skip it. And then what you have to write here? After going from 6, what you have to write here? 9. Because there is no node in the left side. So 9, that is your root node. And then again 10, backtrack, what is the root node? 8, and then last, that is 11. So this is your in order traversal. Same if you have to do for pre-order and post-order, that can be done easily. So we will take another example for the pre-order traversal. In pre-order traversal, that you have to write what? Root node, left subtree, and then right subtree. So in pre-order, let me remove this. What I have to do in pre-order? I have to traverse each and every node by what ways? I have to traverse each and every node by this way. You have to write the root node first, then left subtree, and then right subtree. So let's start with this example again. I have to write root node first, and I am doing what? Pre-order. So root node here is 1. So 1 will be marked. 1 has been traversed. Now what? After root node, you have to go to the left part. So left part here is what? This one. Okay. So in this particular subtree, again pre-order condition will apply. And what is pre-order condition? That you have to write root node first. So root node here is again 2. So 2 will be marked. Okay. Next, when you come to 3, then what is 3? 3 is again a leaf node. It is not having any left or a right. Then 3 will be easily marked. Okay. Then you have traversed root node, you have traversed left side, and then you have to go to the right side. So for the right side, again there is a subtree. This is a subtree. And then what you have to do? You have to traverse it into a same fashion. So what is it? You have to write the root node first, that is 4 first. Then go to the left side, which is 5. 5 has been marked. Go to the right side. There are no nodes for the right side. Then you have to backtrack. So your left subtree has been covered for root node 1. Now I will be switching to the right subtree. So right subtree is having a root node 6, which should be written first. So 6 has been marked. Now I will go to the left side. Left side is 7. 7 does not have any kind of a children. Then 7 will be marked. Go to the 8. 8 again is a subtree, and for 8, you have to see what are the left and right side. So 8 has been marked. Now go to the left side, 9, then left side, no node, 9 has already been marked, and go to 10. That is the right side. And then again backtrack, 8 already been marked, 11. That is the right side. So this is the pre-order traversal. Likewise, in the post-order traversal, we have to go in the fashion that you have to first traverse the left side, then you have to traverse the right side, and at last you have to write down the root node. Okay. Now next, what are binary search tree? So these earlier which we have studied, these are the binary trees. They are having children not more than 2. Any node is having the children which are not more than 2. Now what is binary search tree? Binary search tree is like, you can say these are having the properties that every left side area or left subtree will have the value which is smaller to the root node, and every right side of the area, that is right subtree, will be having the value which is greater than the root node. So we are comparing the values here in binary search tree. So when we are comparing, we are able to see that left side of the node will be having the values which are lesser, and right side of the nodes are having the values which are greater. And we are doing this comparison to which we are taking the reference of root node. So from root node, left side is having lower values and right side is having higher values. So this is particular example in which root node is having a value 8, and the left side you can see all the values of the left subtree are minimum, and to which extent that you are actually comparing this, 8, because 8 is the root node. So here 7 minimum, which is lesser value than 8, 5 lesser than 2, 6. Okay. Now if there is a condition that you have to insert an element in the binary search tree, then how it could be done? So there is a smaller algorithm for this. What does this algorithm says? That you have to compare each and every item from the root node first. Whatever the item, whatever the node that you want to insert, you should say, like, you have to find out the value first, what would be the value of that particular node, and then that value will be compared to the root node. So if item, whatever the item that you want to insert is less than the root node, okay, so this is the condition that you are comparing. If the value of that particular item is less than the root node, then proceed to the right, the item value is greater than the root node. Okay, so if the item value is greater than the root node, then you have to proceed to the right child, because right child is having the values which are greater than the root node. And if the item value is less than the root node, then you have to proceed to the left child. So these are the two conditions that needs to be remembered while inserting the root node into the binary search tree. We have to repeat all these steps until we will find out that there are no other left and right subtree available. So we have to go to the leaf nodes, and after leaf nodes, like if I want to insert 1 here, okay, I want to insert node 1, so it is having a value 1. So what happens is that you have to first compare 1 to the root node. Okay, so root node is 8. Now I said ki whatever on the left side, that will be having the values which is lesser than 8, and 1 is definitely lesser than 8. So where this particular node will be inserted? On the left side. This condition says item will be less than root node, then you have to proceed to the left side. So I'll go to this particular node which is 7. I'll compare again that 1 is far far less than 7. So yes, you again go to the left side of this particular subtree. Then here comes the 5. So for 5 also, 1 is a lesser quantity, you will go to the leftmost side. Then you will come to 2. Now 2 again, which is having higher value than 1, you will go to the left side, but there are no other leaves available. So what will happen is, you don't have to compare again. Now you just insert that particular element on the left hand side. So what will happen at this end, on the left side, you will insert your node which is having the value 1. Okay, and this will be repeated until all the nodes that you want to insert will get inserted. Fine. So let's take an example here. So in this example, we have to insert elements which are these elements 3, 1, 4, 6, 9, 2, 5, 7. You are having an empty binary search tree. So initially you are having nothing in your binary search tree, and now you have to insert all these elements. So basically, if you are inserting in a empty binary tree, the first element will be your root node by default. So there is no kind of a jumbling or any other kind of a method that you have to find out what would be the root node here. It's simple. If you are having empty binary search tree and you have to insert some of the elements, then the first element will be your root node. So here the first element is 3 and 3 is my root node here. So I'll start from 3, that is has been inserted because there is nothing that could be compared to. So 3 will be your root node. Now again, what will be the next one? That is 1. So if I want to insert 1, I have to compare it with the root node. Now I am having root node which is having the value 3. So 1 will be compared to 3. 1 is lesser quantity, then 1 will be inserted on the left side. Now what is the next number? That is 4. Again I have to compare number 4 with my right hand side. With my root node. So root node here is 3 and 4 is the value which is more than 3. So I will go to the right hand side. So the 4 will be inserted on the right hand side. Now what will be the next value? That is 6. Now 6 will be again compared to the root node which is 3, and 6 is a greater value. Then it will go to the right hand side. Now again in right hand side I am having 4. So 6 will be compared to 4, and 6 is again greater than 4. Then it will be inserted in the right hand side. So it will be inserted on the RHS position. Now what is again value that needs to be inserted? That is 9. So 9 will be compared again with the root node, and you can see that 9 will be inserted on the right hand side. Now what is the next value? That is 2. 2 again compared to the root node. You have to see that what will be the value. Like 2 has been compared with the root node 3, then it will go to the left side, and then again there is 1. You have to compare 2 with the 1, and 2 is greater quantity, then you will insert it into right hand side. Now 5. So 5 will be inserted where? Greater than 3, greater than 4, smaller than 6 on the left hand side. Now again last number, that is 7. So again 7 will be compared to 3, greater than 3, greater than 4, greater than 6, smaller than 9. So on the left hand side of the subtree which is having root node 9. So this is the particular example in which we see that we need to insert some of the elements into the binary search tree. Thank you.